Okay, we have here today another integral on the board. This one's from the UNSW Integration Bee, round 1, problem 18. We have the integral of 0 to 2 pi of cosine to the 2023x dx. Okay, I really like these problems with the large exponent on a trig function because it makes it a little difficult to deal with. And I know my method's going to be kind of overkill, but I think I'm going to use this opportunity with the large exponent to use the power reduction formula. Okay, now we have our power reduction formula on the board, and you'll notice here we have an integral of cosine to some exponent n, like in our case it's going to be 2023, and that's how we're going to define this thing. So you notice what this formula does, it takes our integral of cosine to the n, and it just reduces the power, but it only reduces it by 2. So there's a lot of cases where this is not very helpful, because like if we wanted to do this out, reducing by 2, we'd have to do it like 1,000 times. So it wouldn't be very helpful if we had to do this all the way out. But one thing I want to notice this here, just because this formula is our I of n integral, well, it's going to reduce it to this I to the n minus 2. Now, the reason it's going to be helpful in this case is because in our situation, we have the bounds from 0 to 2 pi, which is really going to help us out. Because what I can do is this part here, we can just evaluate this. But you'll notice because of the sine term, when we plug 2 pi in here, sine of 2 pi is 0. And then when we plug 0 in, sine of 0 is 0. So this term goes away because everything's going to be 0. And so really in our case, this part of the formula goes away completely, and we can just start calculating values. Like our integral, this is actually I, so I of 2023, right? So for I of 2023, we have this formula. N minus 1 is going to be 2022 over 2023. And then it's going to give me N minus 2, so this is going to give me I of 2021. And of course, we can do the same thing for this. I of 2021 is going to become 2020 times 2021. And you can see this is just going to go on and on like this forever. So one thing I want to notice, after doing 3 iterations, we've got it down to I of 2018, and we just have a bunch of fractions out front. If we do this all the way down to I of 1, our value for I of 2023, what's happening here is this is going to become 2022 double factorial over 2023 double factorial. We're not going to really worry about what this value is. It's going to be some number, so we're not going to be too bothered by that. But eventually, because this is odd, the last value is going to be I of 1. So really what I'm getting to is, let's see if we can find a value for I of 1. Okay, so for our I of 1 integral, we're just going to be looking at this, and we're just plugging in our n value of 1 here. So what we're going to have is just the integral from 0 to 2 pi of cosine to the 1x, or just cosine x. But this, of course, is very simple. Integrating cosine of x, we get sine of x, and we're just evaluating this from 0 to 2 pi. And actually, this is basically what we just did right here, but let's just do it again. So when we evaluate sine of 2 pi, we get 0. When we evaluate sine at 0, we get 0. So our I of 1 value is going to be just 0. Well, what does this mean for our answer? Well, we're multiplying this double factorial thing times 0. So our whole integral becomes just 0. So really what you can do is just kind of skip right from here to here and just calculate the integral of just cosine. When you get the 0, none of this is going to matter, and your answer is going to be just 0. Okay, good problem. We'll stop it there. Thanks everyone for watching. Have a great day.